I'm JR. I'm the technology marketing engineer here at Celona, which means I get to do the fun hands-on stuff, testing new devices, testing things like IP cameras over CBRS, that type of activity. In today's product demo, we're going to show you how a new site is configured and brought up using the Celona Service Orchestrator platform. And we'll start with the configuration of Celona Edge and APs, which leverages that cloud-native network automation functionality. And then we'll select and provision some SIMs, create a custom device group, and follow the really cool part, configuration of a microslice to support our network application, which is IP video. And at the end, I'll be able to show you a demo of the microslicing in action. So let's get started. When you first log in, you'll see the dashboard, which gives you status and activity across all your sites. And that's where you'll see application-specific performance metrics, as well as our AI-generated traffic classification. The site we configured in this video is being deployed with a local Celona Edge appliance, because we need to have direct connection from the IP cameras to the local network video recorder. Step one, we will enter the address of the location, and you can see that CSO has already made a live query to SAS, and we have 100 megahertz available. This particular site is located in Scotts Valley, California, and we're taking a 100,000 square foot facility with a number of IP cameras. The coverage for that was two APs, two indoor APs. The APs in the edge could already be physically deployed at this stage, on the LAN and active, and waiting for configuration instructions from the CSO. Or you can pre-provision it in CSO, which is really what we're doing here. That means when the Celona Edge comes up, it will start its auto deployment as soon as it has a communication path to the internet. You can see, we'll just briefly go back there a second. The first thing you do is add access points, and those are from an inventory that we assign to you. As I said, they could already be on site. You can search through your inventory, tag them, and add them to the system, add them to that particular site, and the same for the edge. Now, we've scaled from the planner, the Celona planner. We know that we only really need one edge node to carry this much traffic. Again, that could be on a VM, or it could be a physical appliance, Celona Edge appliance. So with the site configured, we then move on to the devices. That's it. That's the site configuration done. I'm going to select some SIMs to assign to that site right now. In this one, we're just going to choose 3. Very simple. You select them, select which site they're to be activated on. They could be multiple sites, and click activate. And the CSO is already now communicating with Edge to let it know that those users are authenticated. It's obviously pretty helpful sometimes to create device groups. What that could be around an app. It could be around a particular set of devices, whether it be gateways or, as mentioned, AGVs and that type of application. And in the background right now, we're adding these SIMs into a device group. CSO is already talking to Edge, and the network is provisioning in the background, and those devices now are part of that CCTV group. After we've configured the group, then we can go and create an application. The system is application aware, so we can create an application that the system will detect, and we can do that using any of the parameters you see here, either individually or as a group. So it could be destination IP, DSCP tag. We're actually going to use a destination IP for this one, because it's just simpler for this specific use case, because we have an MBR with an IP on the local LAN. We can say, okay, any traffic destination there will be prioritized. And you can see we can select that either by a range, or in this case, we've done a /32 to select a specific server. So now we've got our group, our devices. We can add the actual application and the microslicing. We've configured that application. It has the system is now application aware. If it sees traffic going to that destination, it will classify it within this policy we're creating here. Now we want to create a guaranteed bit rate. We're going to use 5 megabits per second. It's on the high side, but if you want 1080p, 30 frames per second, or even 4K using H.265, 5 meg is a pretty good number. And then we can also select quality of service class, which I mentioned before. Here you see we're going to use interactive video, which has a predictable maximum latency of 150 milliseconds. If, for example, there might be some PTZ traffic going backwards and forwards, we might create another microslice specifically for that control plane traffic. But here we're just concerned with the video going to the network video recorder, and that's why we haven't configured anything for the down link. So we have our guaranteed bit rate, we've assigned it to the device group, and now we're going to assign the application to this microslice, and that's it. We have created an application in the system, created the microslice, and the system is now application aware and can prioritize that traffic based on those parameters. So we've brought up the site, we've created the devices, we've added those to the site, we have created the application, we've created the microslice, and that's it. So in under 5 minutes, we've enabled an application-aware QoS end-to-end network using CBRS, which is, I'm sure you'll agree, pretty cool. So in the top right-hand corner, we have a video stream coming from an IP camera behind Cradlepoint AER2200, has native support for CBRS built in. And this one is protected. That is a protected stream. You can see we have 1080p, full HD, 30 frames per second. The blue buffer bar there, that tells you how much buffer we have. We're doing near real time, so it has about 1.5 seconds of buffer. Maximum, you can see that there. Below it, we have a second stream that's coming from a Zebra ruggedized tablet device. Again, 1080p, full HD, 30 frames per second. And that one is in the best effort default microslice, which applies to anything that isn't specifically selected in the system. So we'll start this. Turn the sound down. So on the left-hand side here, you'll see we're using NTOP to get a real-time view of those flows. And you can see that it's the top stream here is our protected stream, and the one below is in the default group. You can see we've had that running for some hours now, and this one's just been brought up. Now watch out as these go. You'll see right now our round robin scheduler is balancing things quite evenly. And in a few seconds, we're going to add an iPerf test to simulate some oversubscription on the network. Keep an eye out on the unprotected stream here at the bottom. You'll see, there you go, the buffer just went. We are going to see now over the next few seconds, we're going to see frame rate drops. We're going to see the buffer drop out. We can see that the video is stuttering. And at the same time, the protected video over the same network, coming with the same AP into the same Celona edge, is completely protected. Nothing is happening to that video across the wireless network. It is being prioritized end to end. So you can see here from NTOP that we have the protected stream still going happily at the top, and underneath we have our iPerf traffic and our unprotected video, which are balanced very evenly by the built-in scheduler in the system. Now, you can see that this is still fluctuating, and actually we're bringing a second iPerf test. But while that runs, and you can see those things being affected there, 3 seconds and you'll start to see the bottom video almost completely stop. We have our second iPerf client. This is an iPhone SE natively connected on CBRS, and an iPad Pro natively connected on CBRS over the network. There's no gateways or funny things going on there, and you can see our round robin scheduler is balancing things very equitably amongst the default traffic, and our micro sliced video is fully protected. And that is micro slicing in action.
Just one in terms of the use case for this. Like, was there a reason why they opted for, or were just it was just like to see if you could do it via CBRS, or is this just they didn't want to run cables? Because I mean, I'm assuming they had to run some cables to power the cameras. I'm just trying to figure out like the justification because we have a lot of outdoor cameras, and we've had plenty of times where the fibers get cut or screwed up. So
Yeah.
obviously CBRS would help, but I mean, we're not getting away from running the cables at some point.
No.
JR, maybe I'll jump in on that one.
Yeah, go for it.
Yeah, I think it's a couple of different reasons why you might look to it. As one is where you can't get cables out to, it's hard to cable or it's too expensive. But there's also use cases in those same types of environments or in different environments where they're looking to do more automated operations. So we're talking with manufacturing and shipyards and rail yards where they're looking at putting a large number of cameras on automated machinery. So not only do they have potentially real-time control traffic for like Profinet or mechanical controls, they also have a lot of video streams going up to a remote operator so that they can monitor what's going on and step in if they need to take manual control of a piece of equipment. So they need all of those protected. And usually those are out in, outdoor areas or indoors in manufacturing plants where it's just not capable to run wiring to those, or it's not feasible from a mobility of the equipment.
Yeah, and maybe just to add to that one real quick, I mean, many locations, they may have power, right? Maybe a lamp post or maybe a mast, they have lighting and so forth. But to run Ethernet cabling or fiber cabling to those locations is usually very costly.
Or even like public safety, like squad cars that are more highly mobile.
So in those cases, they've got power some other way. You're not necessarily running power to it other than, okay. That's always been like our debate is like, well, we like the wireless, but how do you get power to it? You still have to run the cable. But in our case, I'm thinking like a fixed location where there would be or should be conduit. But like you said, those are some good use cases for that. That makes sense. Thank you.
I came to CBRS from the event world. We had to build massive networks in very difficult circumstances in very short periods of time, which meant we had to move very quickly. We could sometimes have only 10 days to deploy a network that's going to support 8,000 people or even 100,000 at something like the NFL draft. And the ability to quickly deploy cameras was paramount. And that generally fell to Open Spectrum, just purely for flexibility reasons. And you can't, if you're there for 6 days, there's no need to get an FCC license. But this, the issues we experienced were interference. Obviously, everyone's fighting against the same thing. When it comes to 5 gigahertz, especially with a lot of wireless ISPs out there, wireless microwave. So, having this guaranteed spectrum is a huge benefit overall, and just that guaranteed spectrum is a big part of it.